Now today's topic is inheritance, interface and polymorphism. So we are going to revise all these things, all these chapters. So first of all, what is inheritance? There is a definition given. So what is inheritance? If a class having some method and you want to use that class into your class. So what will the way? The way is a very simple way, that is inheritance. Okay. So if something you want to inherit, you want to get their function, their variables, all these things into your class, then that will be done only by using inheritance. Okay. And next one is interface and polymorphism. We'll discuss in later. So there are many types of inheritance. First one is single inheritance. So when one class is inherited another class, so that will be a single inheritance. See in the diagram. X is a base class and Y is a subclass, or you can say that derived class. Second one is multi-level inheritance. So there are, see the pictures, there are too many levels, X to Y to Z. So X is a base class, Y is a child class or subclass, you can say that. Why? Because Z is also there. So X inheritance of X goes to Y and Y goes to Z. So Z will get all the function of X and Y. Next one is multiple inheritance. So what is multiple inheritance? So when two classes inherited a single class, that will become a multiple inheritance. But it does not, Java does not support multiple inheritance. It can support multiple inheritance, but in a different way. Means you can inherit a class and also inherit a interface. Clear? That is not given in this chapter. Hierarchical inheritance is there. So when a hierarchy is come, when a tree like structure is come, see the diagram, then that inheritance is become known as hierarchical inheritance. Clear? So some terms are there. Extend keyword is used for inherit the class. Implements keyword is used for inherit the interface. And this keyword is used to use the current object, means variable, or you can say that constructor. Super keyword is used for the superclass function and superclass constructor. Overriding. So what is overriding? So there are too many things which is known as polymorphism. So polymorphism is a concept where one function can be used in a different form. Okay, it has different parameters, and overriding is also there. Both concepts are very different. Overloading is something where so we are discussing two concept. First one is overloading, and the other one is overriding. So overloading is something where you just make a function with different parameters and you call whatever parameters you like, and that function will execute. That function will be executed. Means in simple words, you can say that if a function sum having two parameters like int x and y, and it's a functions having three parameters like int x, y, and z. So when you call sum 3 comma 4, the first function will be called, and when you call sum 3 comma 4 comma 5, then the second function will be called. So that is method overloading. But overriding is something different. When you have the same function name in different classes, means if a class is inherited by the another class, X class has a function sum with parameters in X and Y class also has the same function sum in Y sum Y comma Z. So that when you call that function, then you can say that subclass function. Subclass functions is overriding the superclass function. So that is known as the concept of overriding, where the parent class and child class both have the same name functions, but when you call the child function will override the parent class function. Child class is also known as derived class. So there are different names like derived class, child class, and base class and parent class. Clear? Now, moving on to the next topic, that is data structure. So what is data structure? Data structure is something where you want to locate memory allocation of any variable, how to initiate memory, how to organize the memories variables. That is all about in data structure. So it's all about, it's not a part of Java, it's a part of memory organization, you can say that. But it is very important. Why? Because it becomes very sophisticated when you know where to store the value of a variable and how to store a value for the variable, because the programs needs a variable where different kinds of works. Clear? So there are many topics. Topic one is queue and stack, and that is too much not given in the revising notes, so we are just taking very easy turn. What is queue and what is stack? So queue follow the first last in first out concept. No, queue follows first in first out concept, a FIFO concept. So whenever the first one will come, that will also goes out first one. See the queue, when you in the line is shifted one by one, and that is also known as queue. And stack is something is like a glass filled with ice cubes. You see that the last ice cube will be out first. Why? Because that is last in and first out. That is the concept of stack. So stack and queue have different uses. Means you want to store a memory, you want to store a variable in a memory, and you have to follow any one of the data structure like stack and queue. There is also a linked list is also there. So for that point of view, whichever is suitable for your program, you can use that data structure. You want a static data structure, that will be stack and queues are there, that will be implemented using array. And if you want to dynamic data structure, there is a linked list, there is a tree, that can be also used for dynamic data structure. Clear? And linked list is also have different types, like single linked list, double linked list, ring linked list, or circular linked list, you can say that. And trees have different type of trees, binary trees, aviary tree, b tree, and all these things are there. So queues and stacks, whenever queue have different types like circular queue, double-ended queue, simple queue, you can say that. And stack don't have any types. Stack has a simple type. But that is not given there. Not too much things are there. So in stack only one pointer is there, or you can say that one variable is very important for making a stack, that is toss or top of the stack, you can say that. And queue there are two front variable or pointers are there, that will be rear and front. So rear is for inserting element and front is for deleting, or you can getting out the elements. And in data structure there are only one pointer, you can say that, that is the start pointer, which also denotes that the linked list is started. Clear? Okay, now some newer terms are there. So enqueue is there. Enqueue is a and adding an element to the queue at the rear. Dequeue is there, deleting the, so double-ended queue is discussed in the terms. First one is deleting the queue, that is dequeue, and enqueue is there for inserting the element in the queue from the rear point. Actually, double-ended queue has two types. Means you can delete elements from the both end and you can insert elements from the both end. That's why it is known as double-ended queue. Empty is something that is empty, or you can say that underflow condition is there. So something that is data structure that is purely empty, that is a condition where you want to put elements in the where you want to get the elements from the empty data structure, that condition is known as underflow. And where something is full, something data structure is full, and you also want to insert that data into that data structure, then that will become overflow condition. Clear? Front and rear, as I discussed already. So the next topic is trees. So what about trees? Trees is very good data structure, you can say that dynamic data structure, which is implemented using linked list also in the Java. So whenever you see the tree has leaves, there is a left tree and left leaf and right leaf. So both are having different type of values. You can say that there is a root also, root, left tree and right subtree, right? Clear anywhere? So root is the main element, and the leaves are now getting out from that tree. Now root is the main pointer, you can say that topmost pointer in the tree, and left sub pointers for denoting the left leaves, and right sub pointers for denoting the right subtree. Clear? So binary tree has only two leaves, right and left. Clear everyone? So binary tree is either empty, or is a single node, or has a complete binary tree. So if it is a empty, then that is known as only root is there, that is a empty binary tree. If it has a single node, then that is incomplete binary tree. And it is, if it is has two leaves in all the levels, you can say that will become complete binary tree. There is also a BST is there. So BST is a binary search tree. If you want to search any element in the binary tree, then you can use BST or binary search tree for searching element. Okay, so all the elements which are inserted in the tree, that are in the form of sorting. So you can search the element in the form of sorting and you will get the element. Clear? So that is a concept of binary search tree. There is something very important that is not there, that is in order, pre-order and post-order traversing. See the topic in the book. Okay everyone, so that is the end of the topic, and that is end of the all the things. Thank you everyone.